Good morning, good afternoon, and good evening to everyone. Welcome to the technical session 1C, a fourth international conference on WS4. Due to COVID-19, we all are going through a new normal phase, and the team of WS4 wish you a very safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges the research community is facing at different levels. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience in research activities. To continue further, this conference has received tremendous number of submission, which has crossed more than 700 plus number and 20 plus countries marked through a direct submission and special sessions, out of which 142 papers were accepted by the Technical Review Committee. Once again, we all would like to congratulate you for a research work and to be a part of this success story in a fourth version of this conference. Further, I would like to welcome our session chair to take on this session. Dr. Sanjay Gaur is working as a professor and head department of computer science and engineering at Jaipur Engineering College and Research Center, Jaipur, India. His interest area data, meaning data analytic, cloud computing, image processing, and digital marketing. He's a life member of Computer Society of India. He has a more than 16 years of academic and research experience. Welcome, sir.
Welcome. Thank you, ma'am.
Now, sir, you can start the session, please.
Yes. Hello, participants. How are you? Hello, may I audible?
Yes, sir, you are audible. Go ahead.
Participant, welcome to everyone. And at the first presentation, I would like to invite Mr. Richard Pump with their paper, Evaluating Artificial Immune System Algorithm for Intrusion Detection. Mr. Richard, are you there?
Hello, can you hear me?
Yeah, Mr.
Okay,
Please.
great.
Yes.
Right, let's try sharing this. And okay, I hope you can see the slides. Thank you for the introduction. I hope you're all well. And I'm going to talk about the evaluation of artificial immune systems for intrusion detection. First, I'll start with a short introduction on what exactly the problems are in intrusion detection, why artificial immune systems might be a good fit for them. And then I'm going to explain what exactly they are, present two algorithms and some evaluations about the algorithms, and propose some further work. Okay, so the big challenges of intrusion detection are mostly complexity. We've got increasing network complexity, we've got increasing attack complexity, and usually you manually configure your intrusion detection system. Most of the available market solutions actually require you to download a rule set, to configure your rule set. And if you forget something, that means there's possibly an attack that you will not catch. This increasing complexity comes with increased costs. So there is not only a scientific interest in fixing this problem, but also an economical interest. One idea is that by using machine learning, you could possibly learn a simplified model of the network traffic and find attacks that way. This topic has been intensively researched in the past 20 or so years, but has not found its way into the real world application yet. And the big question that we have to answer right now is why? There are multiple issues with machine learning-based intrusion detection systems. First off, all of those have some false negatives. That means there's some attacks that these systems do not recognize within the test data sets. And as you all know, a single successful attack on a cyber system usually means some catastrophic failure. Also, we've got some false positive rates, meaning that there are false alarms. And you can imagine that a false positive rate of 0.5% on 1 million connections a day are a lot of false alarms that people have to. And the most important thing, possibly, is that the evaluations that are available out there are usually done on a rather old data set. Something that needs to be tackled in order to produce some research that is useful for the practice. Now, I've talked about different problems with false negatives and false positives. And in our belief, we think that artificial immune systems might be the solution to it. There are two main mechanisms in artificial immune systems. The first one is the so-called clonal selection. The clonal selection basically works simply by having some antibodies, and if an antibody detects an attack, it generates offspring, mutated offspring. It's nothing else than an evolutionary algorithm, just creating new antibodies from the successful ones. But the theory in this is that by creating new antibodies from good antibodies, we reduce false negatives. So we produce better recognition results by generating new antibodies. And if we have got more of them, we will detect more attacks. Very simple. For this mechanism, there are two off-the-shelf algorithms that can be easily used. There are some standardized implementations of them. Those are ClonAlk and AIRS2. I'll present them very shortly, but I'm not the detail of. The second mechanism that we've got, which is possibly the more interesting one, is the negative selection. In the negative selection, antibodies are just randomly generated. So you've got some random detectors going around without any qualities, and then they are filtered. How are they filtered? Very easy. You just discard the antibodies that react to something that is not an attack, something that you know is normal network traffic behavior. The same mechanism works inside the body. We've all heard of autoimmune diseases. This is usually the process that prevents those. And the theory behind this is that the negative selection protects against false positives, because you just discard all the antibodies that produce false positives. However, there's no off-the-shelf algorithm for this one. The implementation is trivial, but it's future work for now, because we have decided to just concentrate on what's available right now. The third point that I've talked about is the datasets. Datasets are the basis of good evaluations. You have a shareable basis for evaluations, so you can just give the dataset to another person and another person can do their own research and all that. They have, however, some qualities that are necessary. First off, they must be widely used for comparisons of evaluations. Otherwise, everybody is using his own dataset and you can't compare different algorithms. And they need to be recent to provide an accurate representation of algorithm capabilities. As things are, there are no recent and widely used datasets available. So we decided to just use two. The first one is about 20 years old. It's the NSL KDD dataset. It's an improvement of the KDD Cup 99 dataset, which has data from 1989 from a synthetic network. This dataset has been criticized extensively in other works. Just for your information, the training set contains about 54% of attacks and the test set contains about 57% of attacks, which possibly is not a good representation of real network traffic. The second dataset that we looked at was the CIC IDS 2017. It is much more recent than the NSL KDD dataset, and it only contains about 20% attacks within a total of about 3 million entries. So we've got 3 million connections, 20% of which are attacks, and we can use this dataset for evaluation of recent traffic. Now, machine learning often relies on distance measures. A lot of time you have some sort of distance measure used as an affinity measure to decide if a data point is of a certain class. This, however, has been discussed a lot by Agarwal, who proclaimed that there is a curse of dimensionality. So adding more dimensions to a distance measure usually does not provide more discrimination. There's a very interesting proof of this, but I'll not talk about this because that would put me well out of time. So we need to reduce our data sets. We have between 42 and 58 dimensions, which are way too much. So we need to reduce those. And there are multiple different ways to reduce dimensions in a data set. One of the most well-known is possibly the principal component analysis, which we have not used, but instead we have decided to manually choose dimensions. Why have we decided to manually choose dimensions? We wanted to apply the same dimension reduction to possibly all data sets. So we decided to simply choose locations, times, protocols, and data transferred from the data set and run our detection on that. Okay, so now we've got our data set. I'm now shortly going to talk about clonalg. This is the complete algorithm. What's important for you as viewers right now is that there is a loop, and this loop is a single generation in which new antibodies are generated and evaluated, and the good antibodies are taken with to the next generation, and there is an antibody pool. Which leads us to two assumptions. First off, if we increase the size of the antibody pool, we possibly get better detection results. And if we increase the size or the number of generations, we hopefully get better detection results. So we're going to check that. First, we check the antibody count. You see on the chart on the top, we've got the recent CIC-IDS 2017 dataset, which generated pretty good accuracy. And we've got on the bottom the NSL-KDD dataset, which didn't really provide good accuracy, but it's also very old, so we can possibly discard this. And we see a slight tendency of our assumption in the beginning that increasing the antibody count gives us more accuracy. However, there's a point of diminishing returns. Now, our second assumption was that an increased generation count provides better accuracy. And as you can see in this chart, this does not hold true. The problem with this is possibly a very bad algorithm for generating new antibodies, as mutation and selection doesn't really work well.
Mr. Richard, sorry for interruption. Time is over. You can conclude.
Okay.
Yeah, I think result is the last slide of result.
I've got two more slides, but I can
Yes.
skip those.
Now continue. Now continue.
Okay.
Yeah.
Second algorithm, ARS2, I'm not going to explain it. Theory is we've got resources that are assigned to antibodies. Practical results are too bad to use them. So our overall goals of no false positives or no false negatives were not reached. The ARS algorithm was too sensitive to input parameters, so there's no low-hanging fruit to improve the algorithm. The clonalg algorithm, however, has shown an increasing accuracy with higher antibody count, a decreasing accuracy with the higher generation count, and there's possible improvement of this algorithm by improving the generation algorithm. The negative selection has not been tested yet. The effect on false positives is currently unclear. We've done some work on it, but I have not brought this into this paper. Right. Sorry for going over time.
No, no issue.
Are
It's
there any
nice.
questions?
Yeah, it's a very nice study. But I have a question. I want to ask a question about the ratio of training and testing data. That is 53 and 57. Why you were taking 53% and 57?
The ratio of test and training data.
Yeah. Size of testing and training data.
Within the NSL-KDD dataset, there is a split between training and testing. And this split has been provided by the authors of the dataset, so we just used it. And in the CIC-IDS dataset, there is no split between test and training data. So we did a 10-fold cross-validation. So it just takes 10 parts of the dataset and shuffles them.
It is not an idealistic data set data ratio. You don't think that?
Can you say again, please?
Is it fine? The ratio is okay for study. I think it will be 30-70.
We've wanted to produce a reproducible study, so we just took what was available. We did not discuss if the ratios are okay.
Yeah. Right. Fine. It's okay. Thank you. Mr. Emmanuel is there. Mr. Emmanuel. participant number 2, Mr. Emmanuel.
Might be, sir, he is not available, so we can just go ahead with
Okay.
the presentation.
Yes, yes. Mr. Vikas Upman. Mr. Vikas Upman is available. Yeah. Mr. Vikas.
Are you able to hear me?
Yeah, because
Yeah,
you
yeah.
are audible.
Yes, Vikas. Yes, audible.
Fine.
Vikas, please continue your paper with on investigation of RBFN application for anomaly-based intrusion detection on IoT network. Please carry on.
So good afternoon, everyone. And it's really nice to see all of you, and I'm very happy to present my conference paper here. So this is a paper on radial basis function network, which is based on anomaly detection, intrusion detection system, and in IoT networks. And with this, and I'm the main author of this paper, and I have done it with Professor Nikolai Garanin, and I'm a master's student in information system in the information system from Vilnius Academy's Technical University. And let's start with paper. So agenda of this paper is first is the research aim. What's the aim of the research, and what's the main area of the coverage of this conference paper. And the second one is research methodology. The methodology we have used in this paper that to detect the anomalies in a given data set. And third one is the result, that what the kind of result we got after using the radial basis function network in this research. And fourth one is research drill down, which means there's a comparison between previous studies and this study, that what's the difference between the older one and this novel study. And the final one is conclusion and future aspiration, that what we are going, the main conclusion of this paper and what we are going for the next. So the research aim, let me start with objective. What's the objective is anomaly detection in IoT data sets. As the IoT devices are increasing, so the data they are generating is bit more higher than the normal generation of the data. So there is a requirement of to detect the anomalies in the system. And second one is the WS4 dataset, which is a IoT dataset. And so we are going to do the brief study of the dataset in this research paper. And third one is the investigation of RBF network method. That the RBF network method, which is never used before, it's a artificial neural network. And this is the network. This is the method which is used first time in this research, and the proposer of better solution for this. After that, the result we got here is the accuracy is 99.3% of the accuracy, which is better than the other accuracies, and the very less error rate and false positive rate. So next go to the research methodology. So first let's move with the data description. Now a bit more about the data. This is a distributed smart space orchestration system. This is a DS2OS dataset which is generated from the collection of microservices. So these microservices are generated from washing machine and uh, thermostators and fans, lights, and these all. And 350 more. It has more than 357,000 of the services, which are, you can say, samples, and more than 10,000 of anomalous samples which are detected when the data was generated. And it has 13 features and 8 classes which are defined as the attributes it has 13 attributes, different, which is nominal and continuous, and the normality further divided into 8 classes, which is we can say it anomalous classes here. So let's move forward. So first we did the data pre-processing of the data set, which contains some of the missing information when we move the data or transfer the data into some other manner. So there is a kind of dissemination in the data. So you have to fill those missing problems in the data set. So first we change the data in the formation. Then we use the resampling techniques in the data set, that how we can make it more appropriate for the training and testing of the data set, and some of the parameters like random sampling and size of some subsample with 100% of sample rate was taken. Then the proposed method we have taken here is radial basis function network. It's a bit structure of the RBFN. And if you can see that there is a process that we applied in the data, in the method, that input vectors, k-means clustering, Gaussian function out, there's an output, and there's mean. So if you can see the structure of it, so all those formulas which are used in training and testing the data set, all these are the factors that are applied to RBF network for the pre-processing. After the pre-processing, for the training and testing of the data. So here we go for the experimental results, that the results we got in this data set. So first, some of the data distribution we took is some resampling techniques like inverse selection, and we take the data into 60, 20, 20% of the data, and this is 60% of the training, 20% of the testing, and 20% as a cross-validation. So first we apply the 5-fold cross-validation techniques. So in the 5-fold cross-validation, we got the similar result in the 1 cross-validation. So for the traditional technique, we use 60, 20, 20, 20 for cross-validation of the data. So so these are the evaluation metrics of our study, that the training accuracy, testing, and cross-validation accuracies of the method on this data set. And the accuracy is, we got more than 99.3% in all training, testing, and cross-validation. And in this method, that the training time is very less if we compare to other studies which have been done on the same data set in the same field. So the training time we got is 1/9. Sorry, I can't see a bit. Yeah, it's 196.09 seconds, and testing is 2.09 seconds for this study. So let's go forward. And the research drill down, I covered that the comparative study, the 2 more studies has been done before on the similar data set, which is done by Pal, and he used k-means and Bayes clustering for this particular data set, and he got 96.3% of the accuracy. And similarly, Hassan did it before with the logistic regression, support vector machine, decision tree, and random forest, and artificial neural network. And similarly, he got 98.3 to 99.4. So in our study with using a radial basis function network, we got 99.3% of accuracy. So you might be thinking that 99.4% is much better than the 99.3%, but let's move forward and let's explain it. This is the graph which has been which is done by the Hassan, and if you can see the training part, first graph is a training and second is a testing one. So if you can see that on the less number of samples, this all the methods which were used there are performed very, very worst. And if you can see the ANN in the testing and the training one, they got less than 90% of the accuracy rate in both of them in the testing one. So if you can see our study, that in our study, in the from the small set of instances to the maximum set of instances, we got all the 99.2 to 99.4% of the accuracy in 3 of them: training, testing, and cross-validation. So for the, if after the comparison, we can say that this study gave a very much better result than the previous studies, because the study did not lack in any point of the instances of training and testing. And finally, the conclusion, what we did here is a very good pre-processing step to get the better accuracy. And we have proposed a radial basis function network for this particular data set, which has been never used before. And we got high accuracy and low false positive rate for this one, and low error rate. And if we can say how we can move forward in this particular study, so we can say, if you take the large data, so there's a possibility that this method might behave differently, or so we can use some deep learning or optimization techniques for this particular study. So thank you. Any question?
Thank you, Vikas. Very good paper. Very nicely you present the paper, and all the terminology is very clear. And your experiment graphics visualization is too good for clarify your study and importance of a study as compared to your other previous studies. I have a question about cross validation. If all the tasks will be accomplished by the help of training and testing data, so why we are taking a cross validation? What is the key role of cross validation here?
Cross validation, we already did the 1-fold to 5-fold cross validation. So there is a possibility that if you take 20% of the data, it might there is a possibility that it might behave different if we take 80% of the 20% for training and testing. So it's like you are taking more data for training and more data for testing, less data for training. So yeah, so this is that.
So if you're taking more data for testing, you think that your result will be more purify and purify.
Yeah, exactly.
Yeah. So I think that cross validation should be an important factor for a research paper, any kind of statistical numerical research paper.
Yeah, this is I think cross validation is important if you are doing certain kind of research.
Which method you apply for cross validation?
What?
Which particular method you applied for cross validation measurement?
This is a radial basis function we have applied in the cross validation. So the same.
Right. Okay. Thank you, Vikas. Thank you.
Sorry to interrupt you, Sandesh sir. I have just announced we have another session chair, Dr. Priyanka Sharma. She has already joined. She is a dean of the RSU University R&D. She has joined. So kindly we can consider the comment of the ma'am also from next presentation.
Okay, fine.
We welcome you, ma'am. We will go ahead to next presentation.
Thank you. I am a bit late because I was having meeting. The paper was good. Something original was there, but you did point of view you can note. That's all for my this. I think so. We can go for next if audience is having no questions.
Anybody have any question? Anyone?
Sir, thank you. We can go ahead with the next presentation.
Yeah, Madam Maria.
Yes, please.
Are you there?
Yes, good morning.
Welcome, ma'am. Please continue with your paper.
Yes. Good morning. I'm Maria Laura, a PhD candidate in architecture, and I'm going to present you Architect. Do you see my screen?
Yes, your screen is visible, your PPT is visible, you continue, please.
Okay. So I'm presenting you Architect, which is an augmented reality educational prototype for architectural design, which we developed within the framework of my thesis in architecture, in School of Architecture. So architect the word comes from augmented reality and the word architect, and is an interactive and immersive tool for architects and teaching architecture that enables us to visualize custom-made 3D models and 2D graphics, both in interior and exterior environments. During my research, we launched a questionnaire with 98 participants, all students of architecture, that we observed that 55% of the students had a problem, met difficulties in transitioning between architectural scales, for example, from 100 to 1500, etc. So we set some objectives for our experimentation to develop a tool for learning architectural design, which should be a location-based experience according to the site of building implementation, that would contain a personalized library with multiple virtual objects, and all this with a user-friendly interface for architects that are not necessarily familiar with program coding and all type of software. Several applications exist in this domain, such as Morpholio, Trace, SketchUp CAD, and Archi, applications that merge architecture and the augmented reality possibilities. In our case, we wanted to create, first of all, an educational prototype for architectural design that would be an active and real-time immersion environment for students to understand architectural scale. Plus, we didn't want merely to create a representational tool for visualization of a building, but also a tool for spatial conception and design on site of future building implementation. So our methodology is to prototype Architect as a demo. We based in 4 stages as a framework of development based on this paper, which is mentioned below, concerning augmented reality research for architecture and design. That the 4 stages are augmented reality concept and theory, augmented reality implementation, augmented reality evaluation, and augmented reality industry's adoption. According to this structure, the architect concept is, as mentioned, a user-friendly interface for students in architecture. The personalized library, which contains multiple virtual objects, and the user can manipulate these objects in 3 axes to create immersive walkthroughs into the 3D augmented reality scene, to provide a measurement tool so as to be able to calculate distances, and in general to provide tools that architects are accustomed to using already. 5 steps are necessary to use this application. First of all, when we launch the application, the AR camera, augmented reality camera, is activated. And once this camera is activating, to set the scene configuration, we start looking for flat surfaces so as to be able to enable a grid. Then the interface of the application, which is the object digital library and the toolbar, appear. And the whole interface is ready so as to connect with the real environment and start creating augmented reality scenes from where we can upload and download custom 3D models. The flow chart is that here we have the user, and the user from a portable device such as a smartphone or a tablet can have the application in a standalone setting from where we enable the grid configuration. We have the scene and the interface with the digital library and the toolbar from where we can download and upload objects to a cloud storage, data storage server. And this with the use of a computer, a desktop, by creating an online profile, individual profile for each user in the www.artec.eu. The user can upload his custom-made 3D models. The tools that we developed are very simple, such for a demo, it's the move, copy, rotate, scale, delete, and measure tools. As we see in the images below, the scale mode, we could make simple configurations, digital configurations by placing cubes one above the other and moving them around to create some experimentations with a simple form as a cube. More explicitly, this is the interface of the application. Here, here we see the library. The toolbar contains functions such as hide, measure, rotate, copy object, print screen, scale, and delete virtual object. And the library can contain standard geometries such as a cube or a sphere, 2D graphics such as the trees in 3 different seasons, and 3D custom-made models that we uploaded inside the application. In the second phase, for the implementation of our application, we used Unity 3D to develop the application, and Clojure, which is an formatting language very close to Lisp. And also, it is compatible with both Android and iOS devices that are supported by Google AR Core, the one that we used. About the implementation, we faced some technical issues that we had to overcome. And one was about the grid that was provided by Google. We faced some overlapping when we scanned for flat surfaces, and we had to develop a little bit on this. And also we had to adjust movement in the 3 axes, in the Z axis more particularly, since we had to simulate a 3D space in a 2D screen. For the online platform, we converted all dimensions to meters. We recalculated the object's pivot point to 0, 0, 0 at each point. We had conversion of materials and textures according to different devices. And also we shared about compatibility with several software that most of architects use, such as Rhino, SketchUp, 3ds Max, etc., etc. About the evaluation of this application, we did some experimentations in the city of Paris early this June 2020. At this stage of evaluation process, we evaluated the application and not the content of 3D or 2D models. We used some models that we created and others that we downloaded.
Maria,
Excuse
please
me?
conclude your paper within 2 minutes. Is it possible to you?
I had 12 minutes now.
Yeah, now 10 minutes is over, so you may conclude your paper within 2 minutes.
Okay.
Yeah, please.
So this is the evaluation. I wanted to show you this video.
Yeah.
The results is that that Arctic works with non-stable surfaces from different heights and different distances, such as the height of the bridge. We were able to create 360 view walkthroughs, to have a library with multiple objects, and to prototype a tool for teaching architecture with augmented reality. The conclusion is that new teaching approaches of architecture through immersive interactive environments can be suggested. And also this type of application can facilitate spatial conception and architectural scale understanding on sites on real time. Further work contains functionalities such as material and textures, different lighting simulations and shaders, to adjust to VR capabilities, adjust AR core depth, and to provide, of course, more experiences with students in architecture. Thank you very much, and I'm willing to take your questions.
Thank you, Maria. It's a very nice presentation, and nicely you develop your applications on Arctic. It's very nice. My audible? Yeah. Maria, tell me one thing. Is it possible to work with 4D
How
same
does your
software?
algorithm?
Madam, Priyanka Sharma, madam, are you?
I was asking something. You asked, sir, better. It's okay.
Yes,
I was asked.
yes, you continue, please.
I didn't hear anything.
Priyanka, madam, you are not audible. Please, your voice is not properly coming. Please.
Sandesh sir, she has unmuted herself, so you can go ahead with your comments.
Yeah. Madam, madam, is it possible to work with 4D, 4 dimension, despite 3D?
4 dimension, what do you mean?
I mean that we are working, design all the application with 3 dimensions, right?
The application is supposed to use to function in 3-dimensional space. Yes.
Yes.
Manipulate objects in three directions.
So, is there possibility to work with 4 dimension?
4 dimension.
Yeah.
Means according to time, and to develop such experience for cinema, for example.
Yeah.
So for the time being, it's not possible, but it could be in the further work. It is just in the demo.
Okay, tell me one thing more. What is the buffer size for images in your application?
Can you repeat the question, please?
What is the buffer size in your application?
Excuse me, but I didn't understand the question. If it is the...
My question is, you develop your application in 3D. I want to know about the buffer size for your application. Memory buffer size for your application.
Which is if it is the first time of the application, or something about the memory of the application. For the memory, for the database, is the question?
Actually, I think memory size for buffering the images, multiple images for 3D. That is, I want to know the actual size of buffer size.
I really cannot answer this question.
Okay, no.
Because no. I cannot understand the question.
Okay, I think so. This question's answer, she can find out what sir is asking. Madam, can you tell me how how do you measure accuracy and consistency of this work of this
Yes. One or
in other words, can you say, are you able to hear me?
Yes, madam, continue,
Yes.
please. Yeah.
Ma'am, your connection actually is interrupted. So
Okay, you may think over this also.
we can do one thing, sir and ma'am, you can directly write it down to Maria. Maria, if possible, you can answer the same into the chat,
It is
Fine,
actually
fine.
which is
Or
more
she can
comfortable.
think over the questions.
Yes.
No problem for she cannot answer prompt answer. It's okay. She can just think over it. See, it
Yeah,
is the
actually,
platform to discuss their work. है ना? So best of luck. Thank you. We may go to next participant. Thank you.
Yeah, nice, Maria. The next participant, Mr. Sandeep Unyal. Are you, please, Sandeep Unyal and Deepak Unyal?
yes, Deepak, you can go ahead.
Deepak,
Okay.
are you there?
Yes,
Yeah,
yes, sir.
please come. Your paper is Social Media Emerging as a Third Eye, Detection Users' Sentiments on Government Policies, right?
Yes, yes.
A case study of GST.
Yes, right.
Yeah. Please carry on.
Okay, sir. Okay, good afternoon, everyone.
Yeah.
I am Deepak Niyal, and I am pleased to be a part of this WS4 2020 conference. So, I am presenting the paper on social media emerging as a third eye, and we'll be decoding user sentiment on government policy. It's GST, and I am working as assistant professor in Graphicera University, India, and the second, which is co-author of this paper, is doing MTech from NIT Calicut. So now, without wasting much time, I will be presenting the paper. So table of content or agenda of this paper is I will be providing the introduction first. It will be about the social media analysis, and then I will talk about the methodology. Before that, I will be also discussing a little bit about the GST in just one slide. And then after discussing methodology, I will be talking about the result analysis, and will conclude with its conclusion and future works. So the first part is when we talk about social media.
Deepak, sorry to interrupt you, but we are not able to see your presentation slides. So is it possible you can just
Okay.
go ahead with the share screen?
Okay, I'm sorry.
Share screen.
I think I didn't.
Share screen.
Yes.
Okay.
Can you see it?
Yeah.
Go ahead.
Okay, I'm sorry for that.
No issue. We will continue.
Okay, so let us start with the introduction. So social media analysis is primary means of communication these days, and a lot of people used to use it for the expressing their views or on the products or on the government policies. So everything that is on social media may or may not be authentic or true, because if we see a lot of things these days, like this news I saw few days before. So there is a research of the Carnegie Mellon University, which they analyzed 200 million tweets and found that 50% of the users are like bots, and they are discussing to reopen the America. So everything that is on the social media might not be true, and it might be just an opinion of the user, or maybe they are bots, right? But we have not uh, uh, I will talk about the limitation in the end, but we have not considered this thing in the paper, and we have just considered that everything is authentic, right? So in this paper we have discussed about the GST, which is indirect tax that was applied in the India in 2017, and GST has actually subsumed a lot of, and it is superseded by the GST Council, for which there are almost 34 members. They are finance minister from the each state, and then there is a union finance minister. It actually consisted of three type of taxes. One is central, another is state, and third one is integrated GST. and the tax slabs are actually 5. Some of the streets say that these are 4 slabs because one is 0% in that. There are some products that are not in the GST, that is petroleum, alcoholic, and electricity. Now, research question, as we are doing this study for the opinion mining on the GST. So the first question is, what is the opinion of people on this new taxation system in India? Second question that we are asking to ourselves is, from which area the most tweets are coming? So that means if only few areas from people from only few areas are tweeting or posting the tweets, that means we can't say that whole country is involved in such forming such opinions, right? Generally, we take some data from the Twitter or any other sources, and when we generalize it, we say that everybody is saying like this. But generally, it doesn't happen. Sometimes very few people are talking about that. Third point is, when are the most people posting their opinion? It means we are talking about the daytime, means time of the day at which people are posting their opinions. So the fourth point is, to whom most people are mentioning in their tweets. So we'll talk about in this research to whom these people are mentioning, all those people who are tweeting, like it could be the minister, or it could be the prime minister, or any other minister, or maybe some people in the some corporates. All right. So now I will talk about the methodology of the paper. So we first collected Twitter data from the public Twitter API, and it was more than 1.5 lakh tweets. So that tweets we collected in the month of July for the 3 weeks directly. After collecting the tweets from the public Twitter API, we pre-processed the data. And pre-processing data means, like, first we collected JSON data and then we converted it into CSV, and after that we removed some characters or digits from the tweets that we don't need for the processing purpose, or we don't get some analysis from that. And finally we removed some duplicate tweets from the data, and finally 20,000 tweets were remaining. Now after we we pre-processed the tweet, we applied polarity assignment on 20,000 tweets using NRC emotion lexicon, and it tagged each tweet with some emotions and sentiments. So we will talk about this algorithm in next slide. And after tagging each tweet with some sentiments and emotions, we applied k-fold cross validation, where we took k in the range of 3 to 10, and we applied it to 6 algorithms, and finally did the analysis on those algorithms. And at the end, we performed some temporal analysis and spatial analysis on the algorithms. And next slide. So this is the algorithm that creates a sentiment, that provides sentiment to each tweet. So what we did, we created a sentivector first, and these are the 10 spaces here, 10 zeros that you can see. So two of them are for the sentiments, positive and negative, and 8 are for the emotions. So first we tokenize the tweet and found that word in NRC lexicon. And when the word is found in the NRC lexicon, that had some score attached to that. So if that score is positive, so we updated this sentivector, and that becomes 1 positive. For another token, we again try to find out, and if that is also positive, we'll make it 1 plus 1 2, and so on. And similarly for the scores also. So this becomes sentivector, and after that we analyze this, or we scan this sentivector and find out whether this is positive, negative, or any of the emotions from the vector. So in the result analysis part, we drawn the word clouds for the hashtags from the tweets, and then the mentions. So if you see the A part, word clouds for hashtags, you can see the most of the people are actually positive in that, because if we just look at the hashtags, then most of the people are, if you look at the bigger hashtags, then these hashtags also shows that people are talking positive about the GST for New India, and GST boost for which, and below GST for common man. So these are bigger ones, are positive one. And the people that are tagging much are Narendra Modi, PM of India, then Arun Jaitley, then Finance Minister of India at the 2017, and also other mentions that are in the bigger sizes are PMO India, GST Council. So GST Council is the main council that leads this, and most of the changes are done by the GST Council with meetings. Now in the second part, there is a lot of analysis on this paper on the data. So if we look at the figure A, it shows the number of tweets per day, and the GST was applicable from the 31st of June 2017. So we have collected the 3 days data after 3 days. So in the beginning, the data that people were posting was in higher in number, but slowly it goes down. And then we analyze the cumulative hourly cumulative data. So like we collected every day in 24-hour slots, and found that the time at which most of the people were posting tweets were between 17 hours to 18 hours in the day. And the third figure that shows the day-wide sentiment analysis, that shows that most of the people in any day are positive about the GST, and then after that there are people who are negative, and then some of the people are neutral. Those are either neither positive nor negative. Then in the figure number E and F, it is about tweets that are mentioning Mr. Narendra Modi and Mr. Arun Jaitley. So if you see that spike in between, you can see that most of the people are because that was the time when meeting was conducted, a second meeting was conducted of the GST Council. So that day a spike was seen in that in that day. So most of the people were again positive and showing their trust towards Mr. Narendra Modi and the new tax regime in the India. And then if you look at the figure number D, that is the result analysis of the algorithms that we done. So there are actually 6 algorithms that we perform. So at the lowest level, if you look at the naive base, that is not performing so well. So what we took, we took another algorithm complement naive base, and that performed better than naive base. Naive base is not performing well because this is not good for if we are taking more than 2 classes, or if data is not uniform, right? So complement naive base is performing well, and the best algorithm that has performed is logistic regression or SVM. They are performing nearly accurate. So third part of the result analysis, this table shows we have calculated accuracy, precision, recall, and F1 score. We have calculated all the matrices, and
sorry for interruption. The time is over. This is last sheet of analysis.
Yes, this is last.
Okay, no.
So we have calculated for all the folds from 3 to 10, and you can see that in the K fold cross validation for the value of K 9 and 10, it is performing well. So we should do this now. At the conclusion work, we can see that most of the people are positive in their sentiments, and SPM and LR are performing very well. And third thing, we can see that social media is dominated by a small portion of society. And in our paper, we have presented that almost 70% of tweets are coming from the 6 states of the India. So the last thing is whether all users are authentic or not. So we have to keep this in mind and perform our future research. Again, if all tweets are authentic or not, we can do some future research on it and remove those which are fake. So thank you so much.
Deepak, it's very nice paper and very nicely you present paper, and analytics is so good again. Priyanka madam,
sir, I was just thinking, what will be the utility of this work? Number one.
Definitely.
And number two, first, if you can say, so why we are analyzing data?
Yes.
Because the same concept can be used for somewhere else in some other domain also.
Yes, yes, we can use it in some other domains also. Whenever some government policies are coming or any product in coming in the market, most of the users are presenting their views in the Twitter. So
Okay.
if we present some analysis on that, government authorities can look into that and see if people are happy about it. It's not about GST only; it's about all the
Yeah. The same thing
other
I
things
was
also.
thinking, like views on should be unlocked, it should lock, and then afterwards having the keywords and giving final view of Gujarat people. है ना? This is something which you want to do, right?
Yes, ma'am.
Or if I ask you question in which state cyberbullying type of cybercrime is happening more, for example, then you can say, okay, in this state. So
Yes, yes, right,
policy should be more. है ना? Okay,
right,
nice.
ma'am.
Okay. Floor is open to audience if they can. They at least, है ना, sir? One somebody
Yeah.
to ask from audience so we know how many participants are there. Let me see.
I think I am the last one.
19 participants.
One
19.
more is there. One
Okay.
presentation is remaining. Deepak, my question is which analytics software you are using for whole process?
No, sir. I used Anaconda and means simple plain Python programming
Simple
for
plan,
this.
not any R, Veka type of software.
No. I didn't use that.
No,
I
no.
used
Didn't
Python only.
in Python. Yeah, it is Python
Yes.
is again a programming language for data analytics. And tell
Yes.
me one thing, which tool gives best suitable result, linear regression or support vector mechanism?
Sir, for this data, linear regression performed well. It was and SPM was little lower than that.
Reason behind that? Uniformity of data is the reason or any other reason?
Yeah, uniformity of reason could be one reason behind this, sir.
Okay, so I think a better uniformity, good uniformity means linear regression is better option for that.
Yes, sir.
Yeah. Okay, nice. Thank you, Deepak. Anyone
Most.
participants want to ask question? Anyone? One more paper is there about Emmanuel.
Thank you so much, sir.
Mr. Emmanuel is there.
I think so, sir. Emmanuel or Suyotu, none of the author is available. So
Yeah.
we just go ahead with the closing remark of the same. For the same,
Yes.
I'd like to invite Dr. Amit Joshi for the same. Over to you.
Yeah. Yes.
Hi, good afternoon, everyone, and hope you are having a good time at the session. Dr. Gaur, how are you?
Be fine. How are you, sir? Your
I
look is
I saw a
totally
lot
different.
of newspaper cuttings today.
Yes. Yes.
Anyways, I thank you for your sparing your valuable time and being available here to chair the session on a very short notice.
Sir,
Thank you very much.
this all for you, from with your support
No,
only. With your
it's just
support.
a positive gesture, and my next part of thanks is due to all the authors who have presented so well and who have contributed their papers and trusting us. Although we could not make it this year a physical conference, but we hope that we will all meet again in 2021 for the WS4 at another location in probably London. And secondly, I would like to say two things to the authors, that the whole cycle time of the paper you have submitted, then you got the acceptance, you reviewed your comments, and then you revised your paper, you sent back your paper, and I hope the copyright process of the IEEE is in process. Many of you have signed it, some are still in process, so you will be getting that mail in 1 or 2 days. So you will be signing that copyright, and it will take approximately 3 months for the papers to be online. So the whole cycle time would be around 6 months. So we thank you for patiently waiting and being so patient with us, and raising queries and anything which you want us to do. Or the simplest thing I can say you is, if you feel anything where we can help you out, where you can assist, where we can assist you, please feel free to write to us. Please feel free to drop a mail. We will be happy to answer that. You can directly drop me a mail, our team a mail. We will be happy to answer. Thirdly, regarding the certificates, all the certificates to the concerned presenters will be raised just after the session is over, and along with their payment receipts which you have made, and as well as a thank you letter from on the behalf of our organization. I wish once again all the participants a safe time, uh, great summer, because in London it's really great summer, and London summers are really awesome to enjoy. But unfortunately, we are not there. All of you are not there for being in summer environment. But definitely, we'll hope it for 2021. Until that time, take care and stay safe. Before ending up this session, I would like our team to just present a certificate token of appreciation to Dr. Sanjay, if it is available. Otherwise, we will consider him and we will just share. So here is for you, Dr. Sanjay God. Thank you very much for your support and your time, because seeing a screen continuously for a long time, it's very difficult, and we appreciate your gesture to be a part of this on a very short notice once again. Thank you very much. Thank you all.
Sir, the Dr. Priyanka Sharma is also there to chair the same session. So, ma'am is
okay.
Sir, it's
okay.
okay.
Okay,
It's
Dr.
okay.
Priyanka Sharma. I thought that you will not be joining this session, but anyways, thank you for really,
it's okay.
for you
I am
as well,
looking the
and
same.
I would like the team to present a token of appreciation to Dr. Priyanka as well.
Thank you so much. It's always pleasure for me to be part of this conference, and really we hope we'll meet next year physically.
In 2021,
And,
true. I think Dr. Priyanka Sharma was there when conference of World Expo 2019 was organized at London Met University. So we have a very fond memories there. And
right.
I think many of the researchers who are joining also, they have their memories from there.
It was July 30-31.
Yes. Last year it was.
And we had a very good session. Yeah. So best wishes to all participants, to organizer. I'm so grateful to you for providing this platform. It's always a pleasure to interact with you all. Thank you. Have a good day. Okay.
Thank you very much, and stay safe during this pandemic time. And I hope and I believe that this COVID-19 will soon be a thing of past. Stay safe. Thank you.
Thank you, Dr. Amit Joshi. Once again, I thank you to all the participants. Just I request you, all the participants, if possible, you can just turn on your camera and click the print screen so you have a memory for the same. For next 20 seconds, we can just turn on your camera if possible. Yes, once again, thank you. Thank you so much to all the participants.
Thank you. Please share the photograph.
Sure. Thank you once again. Looking forward to the next sessions. The other sessions are already going on. So thanks a lot.
Thank you.
Okay. Take care. Bye. Stay safe.
Thank you, everyone.